Alright, here in question 4 we have some nomenclature. And we start with a nomenclature of a cyclic compound. Now, where do we start? Well, one thing we hopefully remember is we often want to start at a position where we have multiple substituents, if that exists. Why is that? Well, if we have a position that has more than one substituent, it means our first substituent will be at carbon 1, and our second substituent will also be at carbon 1. So that gives us two possible spots to start. And from there, it should be clear which direction we would go. So if we start here, we would want to go this way because that's where this next substituent is closer. If we start here and go this way, again, that's where the next substituent would be closer. So which one do we choose? Well, in both cases, that isopropyl group would be at 3, and then the other carbon that has multiple substituents would be at 5. So that's not going to help us. So the way we break that tie is we need to look for the substituent that comes first alphabetically. And that substituent would be the bromine. And so we would get numbering for this structure that looks like that. Now we need to name the substituents. Bromine comes first. 1 bromo, 3 isopropyl, 1 5 5. Remember that because that's 2 of the same substituent on the same carbon, we still need to list that number twice. And it's a 7-carbon ring, so we have cycloheptane. Now, are we done? So we're not done yet, and this often ends up being one of the most common mistakes I see on problems like this. What do we still need to do? Never forget your stereochemistry. That's part of the name. So how many chiral centers are in this molecule? We should get 2 chiral centers, carbon 1 and carbon 3. Carbon 5 is not chiral because it has 2 methyl groups, so 2 identical substituents. So if we look at carbon 1, what is our highest priority substituent? Well, 3 of our substituents are carbon-based. 1 of them is bromine. Bromine has a higher atomic number. That's highest priority. Of the 3 carbon substituents, 2 of them, the 2 in the ring, have more carbons attached. The methyl does not. So the methyl would be our lowest priority. Now between the 2 carbons in the ring, we have a CH2 here and a CH2, both bonded to a carbon, so those are the same. And we have a carbon bonded to 2 carbons versus a carbon just bonded to 1 carbon. So we will have higher priority over here. Our lowest priority substituent, the methyl, is already pointed back. And so this goes counterclockwise, or S. All right, what about at carbon 3? So we have a carbon that's bonded to 1 carbon, carbon bonded to 1 carbon, and a carbon bonded to 2 carbons. So the isopropyl is our highest priority. For the other carbons, we're going to have to go 1 carbon further. Up here, that's a carbon that has 2 carbons and bromine versus 3 carbons. Bromine, being higher atomic number than carbon, will win. We have 2 that way, 3 down here. Arrow goes clockwise, or R. In part B, we have a bicyclic compound. So in a bicyclic compound, the first thing we need to do is count all of the carbons within all of the rings. Now, how do we know this is a bicyclic compound, which we use the term bicyclo? Well, if we cut two of the bonds in this structure, we can get to an acyclic species. And so that's how we define that. How many total carbons? Well, we can count them here. And we find a total of 10 carbons. So this is going to be bicyclo something decane. All right, what do we fill in that middle part? Well, the middle part is the number of carbons contained in each bridge. So recall first that these are what we consider the bridgehead carbons. In a bicyclic compound, there's always 3 paths to get from one bridgehead to the other. And so we just need to count how many carbons are in each path. If we go by this path, we have 2. If we go by this path, we also have 2. And finally, if we go by this path over here, we have 4 carbons. And we always put those numbers, the lengths of the paths, in numerical order from highest to lowest. So the name for this compound would be bicyclo 4,2,2-decane.